Okay, let's take this to the next level. Check this out. Inequality symbols. We know what they are. This one, this one, this one with an equal sign, this one with an equal sign. And what we're going to do is we're going to end up plotting the lines onto the graph, but they're going to end up forming something called a boundary. And what does a boundary mean? It's a line or curve that separates the Cartesian plane into two regions. What do I mean? This boundary, think of it as a fence that breaks up a neighborhood into different properties. In this case, if you're looking at a Cartesian plane, that line here is going to separate the Cartesian plane into this area and this area. Two separate areas, and that's exactly what we're looking for. Now, what does this have to do with us right now? I'm going to show you. Remember this equation right here? Minus 2/3 x plus 6. Let's go out and graph that. Let's draw our fence. And this is exactly the same one that we had in the last question. So minus 2/3 x plus 6. 1, 2, 3, 4, 5, 6. There's 6 down to over 3, which looks like right about there. So our graph is going to look like this. Okay? That's what it's going to look like. There's our fence. See what I mean? And we're used to doing this equation where it was an equals to like this. So we would actually draw a line. Bada boom. We're done, right? Not yet. We're not dealing with equals anymore. We're actually dealing with values that are bigger than this line. Think about it. That's what our boundary is telling us. Our boundary is telling us this is the fence, but we want all the values that are bigger and equal to our fence. So we draw our line, bada boom, like that, everything's fine, but we want our values of y to be bigger. In other words, we want the values to be on this side of the fence. Why this side? Because this is the side that is bigger than the fence. This is the side that is bigger. I can't describe it any other way but that. Okay, it's the side that's larger than the fence, and that's what you want. You want this to be greater than. How do you prove that? Well, you know what? Pick a point. I'm going to pick this point right here. I know that that's 6, 7, 8, 9, that's 10. So if you think about that, that's 0.010. Substitute it in and see if it actually works. Test points work so incredibly well. Let me clean this up a little bit so you can see it. So I'm going to take this 0 for x and I'm going to put it in here. Well, look at this. This is now 10. That is now, oh, well, times 0, that's gone. Question, is 10 bigger and equal to 6? Well, of course 10 is bigger than 6. So guess what? This entire region here will work. And that's what we do. We draw a nice solid line like this and shade the area. That works. We proved it by using a test point. Aha. So the question is, when do you draw a dotted line or a solid line? You draw a solid line because this says everything bigger than the fence and including the fence. Look at this guy. There's no equal sign on that. That's when you draw a dotted line, because that means you go up to the fence, but you don't include the fence. Let's draw this guy out and you'll see what I mean. Y equals to mx plus b. There it is, plus 4. 1, 2, 3, 4. There's your b. Down 2 over 5. Okay, down 2 over 1, 2, 3, 4, 5. There's your fence. But did we draw this right? No, because we didn't have an equal sign. This is telling you don't include. Don't include. So again, plus 4. 1, 2, 3, 4. There's 4. Down 2. 1, 2 over 5. 1, 2, 3, 4, 5. There it is. But it says there's no equal sign there. Look, I'll clean it up. You'll see there's no equal sign. So we actually have to draw a dotted line here. So we draw our dotted line, bada, 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 like that. Now, check this out. This means this is our fence. You want values that are smaller. Well, values that are smaller are down here. That's easy. Can you prove that? Yeah, sure. I'll pick a point. I'm going to pick the best point in the world. 0, 0. Of course. That makes all kinds of sense. Let's see if this equality holds if I choose 0, 0. 0, bum, bum. This becomes, guess what? 0 plus 4. So, is 4 bigger than 0? It is. Perfect. I've drawn them correctly. That's what I love about this particular section. Now, again, let's go over here, just do a quick review. You draw a solid line if you've got one of these. You draw a dashed line if you got one of those. Now, here's another part. This shaded part is actually called the solution region. Why is it called the solution region? Because any point in this shaded area solves this equation. That's why I chose a test point here of 0, 10. And we tried it and it worked. Look at this. Any point in this shaded region satisfies this equation, which of course I scribbled out and you can't see anymore. Ah, there we go. Okay, satisfies this equation. Any point down here will work, which is kind of cool. That's what we mean by a solution region. Okay, all right.